So now how do we classify positive estuaries? There are different types of estuaries. So now how we do that is we actually look at two properties of an estuary. Okay, so we look at how much fresh water does an estuary receive per time unit. And this is what we call the freshwater volume, R. How much freshwater? Because what the freshwater input does, it creates stratification. Okay. So we can compare that on the same time unit with the volume of water that the tides move in and move out of an estuary. So this so-called tidal volume is a measure of the strength of tidal currents and the ability of tidal currents to destroy density stratification. So we have two competing features. One can be called the river volume, and the other one is called the tidal volume, and it's the ratio between the two things, R over V, that can be used to classify different types of estuaries. Okay, and I want to show you the different types of estuaries that we have, positive of estuaries. Okay, so let's have a look at this. Let's have a look at the first one. The first one is called salt wedge estuary. Okay, it's a salt wedge estuary. It's one where the freshwater input or the freshwater volume exceeds the tidal volume by far. Okay, so the tides have a relatively small impact of what's happening in these estuaries. And what we find in these estuaries is a so-called salt wedge. It's a layer of saline water, essentially just sitting inside or near the front of that estuary. Okay, so now what we can do is we can characterize the salinity structure of these estuaries, and that's shown here on the left. Okay, so we have the estuary, and you can see 0 salinities reflect the fresh water, and 35 corresponds to the seawater. Okay, so the characteristic of this type of estuaries is that the salinity is very close to 0 all along the estuary. Okay, and in the bottom layer, the salinity is near the salinity of seawater all the way in the bottom layer, and there's a transition zone, the salt wedge. Okay, it's a very turbulent zone. Okay. So if you measure the salinity profiles, okay, vertical profiles, you can do that too here. Here you have station 1, 2, 3, 4. And the bottom panel shows you how the salinity profile looks like if you measure from the surface to the bottom. For example, at station 4, you have a shallow freshwater layer, then the salinity increases, and you end up in the seawater layer. So the largest rivers create these salt wedge estuaries. Okay, for example, the Mississippi River, and you can see the salt wedge here in this salinity measurement. Okay, and the salt wedge itself has only a width of 5 kilometers. Sorry. Okay, so it's a very localized transition zone. Okay, we call it also the brackish water zone. The wedge itself can actually move. It depends on the amount of fresh water. It can move. Often these transition zones are even found on the continental shelf. Okay. So all right, that's one example of salt wedge estuary. So let's see what else do we have.